Good morning. Good morning to all. In last lecture, we have started the second part of this topic, phenol. In organic hydroxy compound, if one or more OH groups are directly attached to the aromatic carbon, then that compounds are called phenols. This is a very, very important class of organic compound. Now, in the introduction, we have studied how that phenols are classified on the basis of number of OH group present in the molecule. They are classified as a monohydric, dihydric, and trihydric phenol. We also studied acidic nature of phenol. Phenol is an important class of organic compound and they are acidic in nature. These are the examples of weak acid and hence also called as the carbolic acid. Okay, on the basis of resonating structures of phenol and phenoxide ion, we have studied why these compounds are acidic in nature, why phenol is acidic in nature, and alcohol do not have such type of acidic nature. Now let us see next point, some of the chemical reactions of phenol, that is carbolic acid. Okay, this is our phenol compound, basic compound phenol. One OH group is directly attached to the aromatic carbon. Now, this phenol is example of aromatic compound. And we know that all the aromatic compound can show electrophilic substitution reaction. This is the characteristic property of all the aromatic compound. For example, benzene, then phenol, aniline, nitrobenzene, all the aromatic compound which having benzene ring, they shows electrophilic substitution reaction. Now, why that compound shows electrophilic substitution? Because in aromatic ring, there are 3 pi bond, means total 6 pi electrons are there, and these pi electrons are just delocalized over and below the plane of ring. Means there is a more electron density on the benzene ring, there is a more electron density on the aromatic ring. Hence, electrophile, we know that electrophile is positively charged. Electrophile means positively charged ion. Hence, electrophile can be easily attacked on the benzene and it undergoes electrophilic substitution reaction. What is meant by electrophilic substitution reaction? The substitution reaction in which atom or group from the molecule is replaced by electrophile is called electrophilic substitution. This is the characteristic property of phenol. Now, there is one question. Actually, at what position electrophile can be attacked on the phenol? फिनॉल वरती कोणत्या पोझिशनला इलेक्ट्रोफाइल अटॅक करू शकतो इन फिनॉल? सपोज दिस फर्स्ट 2 पोझिशन्स आर ऑर्थो, okay, the next 2 positions are meta, and while next this is the para position. Now question is that during electrophilic substitution, actually at what position should be electrophile attack? We can explain that electrophilic substitution on the basis of resonance effect in the phenol. We have studied resonating structures of phenol. Okay, these are the resonating structures of phenol. In OH, there is electron pair, lone pair of electron. It delocalized in the benzene ring. We get number of resonating structure. Okay, now what is the conclusion from that resonating structure? Structure number 2, having negative charge on the ortho position. There is a negative charge, means electron pair at the ortho position. Okay, then what's about the structure 3rd? It having negative charge at the ortho para position, while structure 4th having negative charge on the again ortho position, means here 2 ortho position and 1 para position having negative charge, means there is a more electron density at ortho and para position. The resonating structures of phenol shows that there is a more electron density at ortho and para position, and therefore that positively charged electrophile can be attacked at ortho position or it may be attacked at para position, because that positions are electron rich, that positions having negative charge, आणि म्हणून इलेक्ट्रोफाइल जो पॉझिटिव्हली चार्ज आहे इट अटॅक at the ortho or para position, and thus phenol undergoes electrophilic substitution at ortho or para position. Now let us see some of the chemical reactions shown by phenol. First one is the acylation and Fries rearrangement. When this phenol, our basic compound phenol, is treated with the acetic anhydride CS3 C double bond O O, C double bond O, CH3. This is acetic anhydride. Now this reaction is carried out in presence of base like NaOH and also at high temperature. Means here this phenol is treated with the acetic anhydride in presence of alkali at high temperature. Now what happens here? Here that hydrogen atom from the OH group, it is replaced by COCH3 group. That hydrogen is replaced by COCH3 group, and we get this compound, this particular ester. Remaining part is the CH3 COOH, and thus there is a formation of CH3COOH, and this is nothing but acetic acid as a byproduct. And this main product is the example of ester actually, and name of the compound is a phenyl acetate, and that reaction is called acylation. In this reaction, hydrogen atom is replaced by acyl group. Therefore, it is called acylation. Phenol, when treated with the acetic anhydride in presence of base at high temperature, hydrogen atom from the OH group is replaced by acyl group, acetyl group, COCH3 group, and we get the corresponding phenyl acetate. Okay, this is the acylation. Now, further is the Fries rearrangement. Now, what is the Fries rearrangement? Fries rearrangement is not directly shown by phenol. It is shown by phenyl acetate. Okay, let us see further step Fries rearrangement. पुढची step आपण बघूया. What is the Fries rearrangement? Okay, this is our phenyl acetate. This is our phenyl acetate which is prepared in the first step. Now, this phenyl acetate further on reaction with AlCl3, anhydrous AlCl3. AlCl3 is example of Lewis acid catalyst. What is meant by Lewis acid and base? If compound having ability to accept electron pair is called acid. The compound which having ability to donate electron pair is called base according to the Lewis theory. And those compound, those Lewis acid which are used as a catalyst, याला आपण Lewis acid catalyst असं म्हणतो. For example, AlCl3, BF3, ZnCl2, FeCl3. These are the examples of Lewis acid catalyst. In this reaction, we are using anhydrous AlCl3 as a catalyst. Okay, our phenyl acetate we have prepared in first step, that phenyl acetate on a reaction with AlCl3. What happens here? A specific type of reaction takes place. Okay, now here there is a hydrogen atom on the each carbon. यामध्ये प्रत्येक कार्बन वरती हायड्रोजन आहे. I have shown, suppose that hydrogen is present on the ortho position. Now what happens here? This COCH3 group, that acetyl group migrates from that oxygen to the ortho position. तो मायग्रेट होतो ऑक्सिजन वरून ऑर्थो पोझिशन वर, आणि इथं असणारा जो हायड्रोजन आहे, that hydrogen goes on the oxygen. Okay, here this hydrogen migrates towards oxygen and COCH3 migrates on the that ortho carbon, ortho position la migrate hoto, and we get the product. Okay, there is a COCH3 group at ortho position, but there is one more possibility. This COCH3 can be migrate on the para position. त्याचं मायग्रेशन या para position ला सुद्धा होतं. And here the COCH3 group can be migrates at that para position, and itla hydrogen it goes on the oxygen, and we get the another product. Okay, COCH3 at para position and OH as it is. And thus, when phenyl acetate is created with the anhydrous AlCl3, we get mixture of these two products. Okay, here acetyl group can be migrates from oxygen to the ortho position or oxygen to the para position, and we get the mixture of these two products. What should be the name of this product? Actually, this is example of ketone. It having two functional groups. One is the phenol and second is the ketone. Why ketone? Because there is a C double bond O group. It is attached from one side by methyl, another side by benzene ring. Okay, and such ketone is called acetophenone. जर कार्बोनिल ग्रुपला एका बाजूने मिथिल आणि दुसऱ्या बाजूने फिनिल ग्रुप अटॅच असेल, बेंझीन रिंग अटॅच असेल, then that compound is called acetophenone. Okay, this is the acetophenone. Okay, here also this is acetophenone, CH3 C double bond O, and from the another side there is a benzene ring, acetophenone. Okay, but in the acetophenone there is hydroxy group at ortho position, hence it is ortho hydroxy acetophenone. It is ortho hydroxy acetophenone. What's about the second? There is also acetophenone, but OH group is present at the para position, hence it is para hydroxy acetophenone. And thus phenyl acetate on reaction with anhydrous AlCl3 undergo, actually this is called rearrangement. That reaction is called rearrangement. Why it is rearrangement? Because in this reaction there is no any substitution, there is no any elimination, there is no any addition from the outside, just there is a migration of group from one position to another in the same molecule takes place. Therefore it is called rearrangement. Okay, there is a mixture of orthohydroxyacetophenone and parahydroxyacetophenone. Reaction is called Fry's rearrangement. Reaction is the Fry's rearrangement. This reaction is not directly shown by phenol. Phenol directly दाखवत नाहीये, पण कोण दाखवतं? Phenyl acetate. And this phenyl acetate can be prepared by using phenol. Phenol on reaction with acetic anhydride, we get the phenyl acetate. Okay, and that phenyl acetate further on reaction with anhydrous AlCl3, we get the mixture of orthohydroxy and parahydroxyacetophenone. Okay, this is just about the first chemical reaction, acylation as well as Fry's rearrangement. This is our phenyl acetate. Suppose it is treated with the anhydrous AlCl3, and if that reaction is carried out at room temperature, at low temperature, 298 degree Kelvin, this is just room temperature. Now what happens here? The migration of acetyl group takes place at para position easily, and we get the para-acetophenone, para-hydroxyacetophenone as a major product. And suppose reaction is carried out at high temperature, 438 degree Kelvin temperature, then migration of acetyl group takes place at ortho position, and we get the orthohydroxyacetophenone. Okay, that means migration of that acetyl group maybe depends upon temperature condition of reaction. If reaction is at room temperature, low temperature, then para product is major, and if that reaction is carried out at high temperature, the ortho product is the major. Okay, this is just reaction condition for the Fry's rearrangement. Okay, now let us see next one. यामध्ये पुढची रिएक्शन आपण बघूया. Formation of ether and further cleanser rearrangement. First, we will see how the ethers are prepared by using that phenol. Now, let us see how that phenols can be converted into ether. Suppose this phenol is created with the base. If we are using base, then in first step, there is a formation of sodium salt of the phenol, because phenol is acidic in nature. Here, that hydrogen is easily replaced by sodium. So sodium na replace hoto, that hydrogen and OH form minus H2O, and there is a formation of sodium salt of phenol. किंवा आपण त्याला sodium phenoxide असे म्हणतो आहोत. Okay, this is sodium phenoxide किंवा sodium salt of phenol. Okay, in first step, when phenol is created with the base, easily hydrogen is replaced by sodium. We get sodium salt of phenol. Now it further on reaction with any alkyl halide. Suppose ethyl iodide. Okay, what happens here? That sodium is replaced by alkyl group. That sodium is replaced by alkyl group. We get the corresponding ether, and this is nothing but the ethyl phenyl ether. The name of compound is the ethyl phenyl ether. Okay, this is just about the ether formation. We can prepare any ether by using phenol and alkyl halide. Thus, phenol, when created with the alkyl halide in presence of base, in first step, hydrogen atom is replaced by corresponding metal. So here sodium metal, we get the sodium phenoxide or sodium salt of phenol. असे याला आपण म्हणतो. It on further reaction with alkyl halide, ethyl iodide, that sodium is replaced by ethyl group, and we get the corresponding ether, that is ethyl phenyl ether. Okay, this is just a first example. I will take one more example regarding the same reaction. Again, when phenol is created with the aqueous NaOH, in first step, that hydrogen is replaced by sodium. We get the sodium salt of phenol. It on further reaction with allyl bromide. या कंपाऊंडचं नाव आहे allyl bromide. Now what happens here? Here also same type of reaction takes place. That sodium is replaced by this allyl group. Yeah, group na sodium replace होतो है, and we get the corresponding ether. And this is nothing but the allyl phenyl ether. Okay, this is just about the formation of ether. We can prepare any ether by using phenol. Just the phenol is created with the allyl bromide in presence of aqueous NaOH. In first step, we get the sodium phenoxide, means hydrogen is replaced by sodium. Further on reaction with allyl bromide, sodium is replaced by allyl group, and we get the allyl phenyl ether. Okay, this is the ether formation, first part of this reaction. Now let us see second part, cleanse and rearrangement. Now this allyl phenyl ether, याची पुढची रिएक्शन कोणती आहे बघूया. दिस अलील फिनिल इथर फर्दर ऑन रिएक्शन इट इज जस्ट स्ट्रॉंगली हीटेड. That allyl phenyl ether is strongly heated at temperature 200 degrees Celsius. What happens here? Here also, this group, allyl group, undergo migration. It migrates from that oxygen to the ortho position. It migrates from oxygen to the ortho position. Okay, we know that this carbon having hydrogen. Now this hydrogen atom, suppose there is one hydrogen here, this hydrogen goes on the oxygen, it becomes OH, and here there is allyl group, and this is nothing but the ortho allyl phenol. Here also there is no any substitution, there is no any addition, there is no any elimination, just there is a migration of allyl group takes place from oxygen to the ortho position, means from one position to another in the same molecule. Therefore it is also rearrangement, and name of this reaction is the Clenzen rearrangement. आपण allyl phenyl ether ची रिएक्शन बघतोय. आपण मागच्या स्लाइड मध्ये काय पाहिलं, हाऊ दॅट allyl phenyl ether is prepared. It can be prepared by using phenol. When this allyl phenyl ether is strongly heated at 200 degrees Celsius temperature, that allyl group migrate from this oxygen to the ortho position, आणि इथं असणारा हायड्रोजन जो आहे, that hydrogen goes on the oxygen, तो ऑक्सिजन कडे जातो, and there is a formation of such compound, and this is nothing but the ortho allyl phenol. Okay, and that reaction is called as the Clenzen rearrangement. This particular reaction is very important reaction, Clenzen rearrangement. Okay, this is just about the formation of ether, formation of allyl phenyl ether, and Clenzen rearrangement also. Okay, let us see one more. यामध्ये आणखीन एक example बघूया. Suppose this is the allyl phenyl ether again, but in the case that compound if strongly heated at 200 degrees Celsius. Now here both the ortho positions are blocked. In this case, both the ortho positions are blocked because there are two methyl groups are there. There, in that case, allyl group migrates at para position. It migrates at para position, and we get corresponding para product. Okay, this is the corresponding para product. Now, it occurs only if two ortho positions are blocked. In the case of Clenzen condensation, if two ortho positions are blocked, then migration of allyl group takes place at para position. Okay, this is just about the formation of ether as well as Clenzen rearrangement. Okay,